Welcome to qnawire.
This question said we should draw the Lewis structure of hydrogen peroxide. So we have H2O2, right? So the Lewis structure will look like this. We have H, O, O, H. So how many electrons do we have? So this is hydrogen is group 1, so 1 times 2 will be 2. Oxygen is in group 6, 2 times 2. 2 times 6 will be 12, so that's 18 electrons. So put that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then yeah, 14. This should be 14 electrons. Okay, so this is the Lewis structure. Okay. And B said that what is the weakest bond in hydrogen peroxide? The weakest bond is the whole bond. C said we should calculate the longest wavelength of light that has sufficient energy to break the weakest bond in hydrogen peroxide. So the wavelength of light to break the whole bond. So we need to have an idea of what the bond strength of the whole bond is. So we know H or H, when it breaks, you form H whole radical plus H whole radical. And the entropy for this reaction is 142 kilojoules per mole. Okay, so for one molecule, the energy will be 14200 joule, 1 mole times 1 mole divided by 6.02 times 10 to the power 23 molecules. And this will give us 2.358 times 10 to the power minus 19 joules. So then we can calculate wavelength because we know the relationship between wavelength and energy. And therefore, wavelength will be equals to Hc over lambda, and that will be over E. And that will be equals to 6.626 times 10 to the power minus 34 jouleseconds times 3 times 10 to the power 8 meter per seconds divided by 2.358 times 10 to the power minus 19 joules. And that will give us 8.4 times 10 to the power minus 7 meter, which will be around 840 nanometers. So that's the wavelength of light that's required to break the whole bond.